There are 58 million signs on U.S. highways. These signs affect 157 million American road users. In fact, the average American spends 2 years of his or her total lifetime on 6,194,650 kilometers of public roads. When one state highway agency conducted an inventory of their signs, they found 12% deficient in retroreflectivity and 4.8% of them missing. Their results are typical nationwide. Inspection and maintenance are crucial to ensuring a high level of public safety. Poorly maintained signs can affect safety, traffic operations, and can cause severe liability problems. On the other hand, proper inspection and maintenance help assure effectiveness of a highway system, and they provide great benefit in terms of safety at low cost. In this program, we will cover sign inspection and maintenance. We'll look at sign maintenance facilities, field equipment, and materials. And we'll consider how to measure whether signs are performing at the proper level. Then we'll describe a sign inventory system in general and show how inventory data can be collected and stored. An inspection program is crucial to an effective maintenance effort. Proper inspection procedure begins with a review of office records. Inspectors transfer basic data on location and type of device to inspection forms. Next, inspection teams perform nighttime drive-by inspections. They look for signs not reflecting properly, as well as for signs that are missing, defaced, or existing signs that are not in the record system. Of particular concern are signs which are blocked by foliage. The next day, an engineer reviews the results of the drive-bys and arranges for follow-up by the maintenance department. The crews will repair or replace defective and missing devices and move those that are located improperly. A coordinated inspection and maintenance system has several benefits. It aids planning and scheduling of sign maintenance activities. It monitors retroreflectivity performance. It improves safety and reduces liability. Sign maintenance includes field crews and equipment, but it also involves a sign shop and materials, and it involves standards of performance and cost control techniques. Sign shops vary in size. An agency may make all its signs at one central location or spread the work out to the district level. On the other hand, some agencies buy all their signs from outside vendors. Decisions on what size to make a sign shop are based on such factors as how many signs the agency maintains, cost of labor and materials, and space availability. A typical sign shop contains computer layout equipment, exposure frame and lights, heat vacuum applicator, squeeze roller, screen table, drying racks, fans, and more. As work progresses from raw materials to finished sign, the process should be smooth, clean, safe, and healthful. In the field, equipment needs vary quite a bit, from a single wrench needed to tighten a bolt to a crane to reach overhead signs. Generally, however, crews will need a sign truck. The International Municipal Signal Association has manuals that will help in truck selection. Crews will also need a washing device and a variety of equipment such as post drivers, chainsaws, and floodlights. The basic materials needed are sign blanks, sign faces, and sign posts. Let's look at each. Sign blanks are usually either wood or aluminum. Large pieces can be cut down, but most agencies buy pre-cut aluminum blanks. Pre-screened sign faces are also available. There are 4 ways an agency can make its own sign face: silk screening, overlay, stenciling, and hand painting. The overlay technique can combine with the computer to save time and money. The computer handles layout, cutting of retroreflective material, and storage of designs. This method can save the space used for storing stencils. Many highway agencies refurbish rather than replace sign faces to reduce materials costs. Using a mechanical stripper, a field crew strips a sign face of its retroreflective coating without damaging the metal. Then they apply an overlay of new retroreflective sheeting to the sign face. This process results in a 25% cost savings by comparison to replacement of the sign. Sign posts are made of steel, aluminum, or wood, and they come in a variety of shapes. According to American Association State Highway and Transportation Officials standards, the post must be strong enough to resist twisting in the wind or collapsing from the weight of snow or ice. At the same time, it must be designed to break away if it is hit by a vehicle. Sign maintenance budgeting is based on several factors: the size of the signing system, agency sign replacement policies, types of materials used, the level of vandalism, weather conditions, and personnel costs. A major factor in controlling costs is performance measurement. There are several ways to measure performance. First, set a level of service for maintenance. The level of service defines a threshold deficiency standard. In other words, when should a sign be replaced because it is not serviceable? In order to maintain a sign legibility threshold standard, the procedure is as follows. Schedule daytime and nighttime inspection of signs. Clean or replace illegible signs as soon as possible. Replace damaged regulatory and certain warning signs immediately, and replace other damaged signs as soon as possible. Another measurement is through productivity standards. Productivity standards are formal criteria for a specific work activity. The criteria establish what work is needed, proper work steps, what resources are used, how the work should be done, and how quickly. Another measure of performance is the service life of material and equipment. This method is based on reliability, maintainability, and damage resistance. Then there is material control. In other words, by carefully monitoring sign inventory, supervisors can determine how long signs are lasting in the field. Finally, there is fiscal control, which involves life cycle cost analysis. By figuring the cost of fabrication based on labor, overhead, and all materials, adding to that the cost of installation, then comparing the total cost to the service life of the sheeting material, and by figuring in the benefit of longer service life, relative cost per year of useful life for various sign materials can be determined. But these techniques require an accurate sign inventory. Most agencies keep sign inventory data. They collect it and store it in a variety of ways. But they agree on one thing. Without an orderly inventory system, they could not plan and perform maintenance efficiently. A proper inventory will provide details about each type of sign, its location, and other information, including condition. This is a typical inventory control area. The inventory system serves their needs well. A system like theirs should contain all traffic signs in the highway right-of-way. It should use a standard location reference system so that accident data can be merged with sign inventory data. This makes it easier to consider the effect of nearby traffic signs when analyzing accidents. It should be flexible, allowing the addition of new entries, deletion of old ones, and sorting of entries by location. Users should be able to find a sign by location and with the help of word descriptors instead of numerical or letter codes. The system should also allow recording of completed maintenance work and provide multi-level historical records of earlier sign work. And all this updating should be possible to do in an efficient, easy-to-use, and understandable process. The first step in developing a system like this is data collection. At the basic level is a manual system using data collection forms, index cards, and strip maps. Collection and storage do not always have to be computerized. The method used does not matter as long as it works well. The information can be transferred to computer later if desired. More sophisticated additions include photo logging and its more modern counterpart, video logging. And with the addition of the computer in the field, so an operator can enter information on the spot, we have semi-automated data collection. Regardless of the system used, the same specific information is being collected. It includes a unique sign identification number, the name of the street or route, details about the sign location, like number of meters and compass direction from nearest intersection, the name of the reference cross street, the direction the sign is facing, a sign code which can be based on the Manual on Uniform Traffic Control Devices designation, the sign's dimensions, the date of the observation, the remaining life of the sign based on its face material, installation date, and the manufacturer's warranty, the sign's condition. Is it good, fair, damaged, rusty, or what? The type of support the sign has. Is it a U-post, square post, utility pole? The condition of the support. Good, fair, bent. And does it conform to the Manual on Uniform Traffic Control Devices in terms of color, legend, shape, and vertical clearance? The sign's visibility. Is it good, rotated, obstructed? The laptop computer has become a highly useful tool for sign inventory systems. It is portable, so personnel can easily take it to the field. There, the field data can be entered in a more permanent form. Programs already exist for assembling and maintaining sign inventory information. As the program displays individual sign records on the laptop screen, The user can add or change inventory information, such as location, mile marker reference, plus such items as available retroreflectivity, complexity of visual scene, highway curvature, and geometric conditions. Back at the office, the user can display records from a sign inventory file, enter, display, or modify sign material costs, and finally, generate a report using the inventory file. Computer software will track age and condition of signs and apply field data to a model which will predict when a sign is likely to need replacement. Various sign inventory reports are available also. There is a sign dictionary corresponding to functional categories in the Manual on Uniform Traffic Control Devices. And the computer will generate cost-benefit analyses to aid in material purchase decisions. Even newer technology is in development. The U.S. Federal Highway Administration is testing a mobile traffic sign evaluator. It consists of a van with laser rangefinder, a wide-angle aiming camera, a telephoto video camera, a high-intensity xenon flash unit, and a computer. This prototype can measure the sign reflectance by day or night at normal driving speeds. It requires only a driver and operator. Inspection and maintenance are crucial to ensuring a high level of public safety. Poorly maintained signs can affect safety, traffic operations, and can cause severe liability problems. On the other hand, proper inspection and maintenance help assure effectiveness of a highway system, and they provide great benefit for low cost in terms of safety improvement expenditures. In this program, we have covered sign inspection and maintenance. We've looked at sign maintenance facilities, field equipment and materials, and we've considered how to measure whether a sign is performing at the proper level. We described a sign inventory system in general and showed how inventory data can be collected and stored. For more information on other IRF videotapes, call the International Road Federation at the numbers on your screen.